Hey folks, so we're talking about assignment 5 now. We're going to go through 2 through 6. Even though I don't think all of 2 through 6 are going to be assigned, we're going to do them anyway. So for number 2, we're going to start by looking at cosine of x. Now remember, cosine of x looks like this, right? This is the one that keeps on going up on all those even problems because every single cos of x. So that's what cos of looks like. And remember, cos of x is even and it always has the even numbers. And what they ask us here is, hey, if you want to approximate this, if you want to use this, so we're just using the first two terms, right? And we're going to use this to approximate cos of x, right? We're saying, hey, this is cos of x. And the question is, how far off are we going to be? Well, if we remember the error bound, right? The alternating series error bound says that the magnitude, how far you're off going to be, is going to be less than the next term, right? So the error is going to be less than the next term. The next term is going to be x to the fourth over 24. So you can say, this is going to be some approximation, but we're going to be off by some number that is less than x to the fourth over 24. So we know that we're going to be too low, right? Because, every time we do alternating series, we're always going too far. You start off at 1, you go down x squared over 2. You went too far. You go back. You're going back up to x to the fourth over 24. You've gone too far. You go down. So in this case, we're too far down. We're going back up. So we know our error is too low. And we are too low by this magnitude. Well, what is this magnitude? Well, it depends. What our x is. If we say that's estimated at point 0.01, we'd plug in 0.01 here. They said, what happens if you figured out 0.5? You say x bar is less than 0.5. Sorry, x bar, I mean absolute value of x is less than 0.5. So if that's the largest possible value of x, 0.5, if you plugged it into here, you're going to get the error has to be less than 0.5 to the fourth over 24, which, let me get my calculator out, 0.25 squared. So that means the error is going to be less than 0.00260417 according to my calculator, and I may have made an error. So that's what I think. Your error is going to be less than that amount, and we're going to be too low. Number 3. Write the first non-zero terms of the general term. So we know this, right? We know that this one here, we talked about this one already. We've said that, hey, this is just the geometric series, right? Keep going. Right, and this is what we talked about, and this is true as long as x is what, between 1 and -1, right? That's the interval convergence. So this is 1 over 1 minus x. So this is this function. 1 over 1 minus x is our function, and that's the Taylor expansion of it. So they say, write the first four non-zero terms and the general term. So these are the first non-zero terms, and the general term is just x to the nth. Okay, so they say, well, do the same thing for g of x. Well, if g of x is 1 over 1 minus 1 plus x, we have to recognize that this is just f of negative x. So really all we're doing is replacing every instance of x with negative x. Then they come in and say, do h of x, in which h of x is 1 plus x. Oh, so now it's 1 plus x squared, so it's literally g of x squared, right? So we're just taking everyone. So here what we did is we just plugged in negative x for x, right? So we just plugged negative x to get here. We plugged in negative x to get here. We plugged negative x here too, but negative x squared just becomes plus x squared. So that's all we got here. But now all we're doing is replacing every instance of g. We're going into g and we're replacing every x with x squared. So we're just replacing every x squared. So that's just x squared cubed, right? X squared cubed. That's where the x to the 6 is coming from, in case you didn't follow. So I guess it's, oh, that's kind of weird, right? It's going to be what, negative x squared n? Yeah, I think that's right. Okay. So that's kind of neat. Okay, so we're moving on to number 4. For number 4, we are told that the derivative of the inverse tangent of x is, and we know this, right? This is nothing new. The derivative of, the inverse tangent is 1 over 1 plus x. But this is, if you look at the previous problem, this is h of x, right? So we can then think that the tangent is some function that is like the antiderivative. It's kind of like the antiderivative. If this was some function, let's make some new function called big H of x, right? And we define H of x such that H prime is little h. Well, then this is big H, right? It's the antiderivative of little h. So we just did little h, right? Little h is 1 minus x squared plus x to the fourth. We just did this in the previous problem. We should really write this. I guess we can write this like this. It's a little bit easier to work with when you're taking the antiderivative, to have it written that way. Because it's just easier to take the antiderivative if you think of that as a coefficient. Because now we're going to find the antiderivative of this, right? Tangent is the antiderivative of this. So let's take the antiderivative. Antiderivative is going to be x minus antiderivative negative, the integral, right? We sometimes call it the integral. We're just really taking the integral of this entire function, folks. Then we have to take the antiderivative of this. And what do we do when we take the antiderivative? We add 1 to the power. Then we divide it by that. So that looks like the right answer. That's pretty cool. So that's the Maclaurin series for the inverse tangent of x. We probably need a plus c. We just took the antiderivative, right? When we take the antiderivative, we need a plus c. There should be a plus c here. You're wondering why didn't it have a plus c? Well, there is a plus c. But then what do we have to do? We have to kind of plug in 0. And let's plug in 0. We'll plug in 0 here. You get 0. Inverse tangent of 0 is 0. 0 minus 0 plus 0 minus 0 plus 0. All these zeros plus c. So therefore, what does c have to be? C has to be 0. So therefore, we don't need that, right? There is a c, but it equals 0. So that's why that is our final answer right there. Before we move on to number 5. Number 5, f of x is the cosine squared of x, which we know because we know our half angle is the same as this. Again, folks, you do want to know these. You do want to have this down. We spent enough time with this for you to be able to turn this and this into what I have written up here. Okay, so we've done cosine already, right? We've done the cosine so that we know that the cosine of 2x is 1 plus, let's look up real quick. Cos of 2x, right, is this. Way up here at the top. That's the cos of 2x. So now we're just going to replace all these x's with 2's. That's all we're doing. We're replacing these x's with 2's. So I'm putting that squared over 2 factorial. That should be it. That should have been a minus. That has a minus. Okay, now we have a plus 2x to the 4th over 4 factorial minus 2x to the 6th over 6 factorial. And this keeps on going up. And we can just call this, 2x to the 2n over 2n factorial. I think that's what we called it, right? So, okay. Oh, did I forget the negative? I forgot the negative. There's a little negative in here. Whoops. Gotta have that too for the general term. If I plug in 0, do I get the right term? Yeah, if I plug in 0, I get the right term. So that looks like it's right. Okay. We can distribute this, right? We get 1/2 plus 1/2 plus 1/2 plus 1/2 is 1. So we can leave that as 1. Minus 2x squared. Okay, so we have 2x squared over 2. That's the half is 2 times the 2 factorial. Plus 2x to the 4th. We get the 2 there times 4 factorial. Minus, how many of these do I have to do? Let's see. 4. Good. This will be the 490 term. But this could take me a while. And then I'm going to need that general term. That general term is just going to be what? Negative 1 to the n. 2x to the 2n over 2 times 2n factorial. That 2, again, is from that 1/2 that was distributed. This is technically correct. I mean, no one will want to see it that way, so we should clean it up. 2 times 2 over 2 times 2. I think that's just 1. What's that? 2 times 2. That's 16 over, what's that? 16 over 2 times 24. That's 16 over 2 is 8. So 8 over 24 is 1/3. X to the 4th. Oh, well, this is not good. 2 to the 6th over 2 is just 32 over 720. So that's going to be what, 16. Take out a 4. 8 over, take out a 4 of that, it becomes 180. Take out another 4, we'll get 2 out of 45. I think this general term remains unchanged. So there is the Maclaurin series for cosine squared of x. Huh, it's kind of neat. Let me see, does that look right? Yeah, it checks out. The answers look like they check out, which is good. All right, number 5's done. We're moving on to number 6. All 4 parts of this. Okay, write the first 4 terms in the general term of the Taylor series for x. Okay, so around x equals 2 means we have to do this first, right? We're going to start at 0. And we're going to have this over n factorial x minus 2 to the n. Okay, so remember we have to think about what this is going to be. And the good news is they gave us, right? They told us this has a formula. They were so nice. They said, hey, that's a formula. You have a formula for that. So this x, the nth derivative of 2, right, is n plus 1 factorial over 3 all over n factorial times x minus 2. And this simplifies, right, folks? This simplifies to just n plus 1 over 3, right? The n factorials cancel out. Awesome. So when we're going to write this Taylor series out, what do they want? The first 4 terms of the general term? Okay, so when we write these first 4 terms out, we have to remember the rules. The rules are to say, we're going to first start off with, f of 2 over 0 factorial x minus 2 to the 0 plus f prime of 2 over 1 factorial x minus 2 to the first f double prime of 2, right? That's what we're going to be doing. How many do I need? 4? I'll write them all out. So these are the first 4 terms. Oops, that should be 3. And then we're going to have this general term too. And the general term, it looks like what we have right above it, right? That's the general term. This is kind of the general term here, right, folks? But let's write these first ones. F of 2, well, f of 2, we can't use this formula for f of 2. Why? Because f of 2 isn't a derivative, right? So we really need to know what f of 2 is. So I guess we need that. Is that somewhere given? F of 2 equals 1. Good. So they had to give you f of 2. So f of 2 is 1 times x minus 2 plus f prime of 2. What's f prime of 2? Well, f prime of 2 we can plug it in. Or we can just, instead of using f prime of 2, we could if we want to, right? But we could just use this formula instead. But we could find f prime of 2 by plugging in, well, we'll do plug in 1 here. So 2 factorial over 3 is 2/3. So we need 2/3. By the way, this is 0. My bad. Sorry. That should have been just 1. F prime of 2. I guess I'm going to start not getting a little lazier. I'll just come up in here, right? Because if you can just plug in 1 here, you get that. If you plug in 2, you're going to get 1. So 2 gets you 3 over 3. Or just 1. Now come up here and plug in. Oh, we get 4 over 3. Plug in 3. Obviously, this is 1, so you really wouldn't need this. And then at the end of the day, what do we have? We're going to have n plus 1 over 3 times x minus 2. And that's the general term. Okay. Let's move on to, this is what, part A? See, is our answer right? No. Why is our answer wrong? Oops. I made a mistake. I did a copy error right here. I did a copy error. I missed the little n here. That means we have to go back and change everything. Darn it. Okay. When I plugged in 1 here, we get 2 over 3. So this is still correct. When I plugged in 2 here, I needed 3 over 9. And this was 4 over 27. And then it needs an n there. So let's write this out to make it a little cleaner. This is now 1/3, right? I should look over at the answer key in real time. Wouldn't that take away all the fun of watching me make my errors? Okay. Now let me check. Yeah, that looks better. I mean, written a little bit differently, but yeah, that looks like better. Okay, so now we're going to do B. Find the radius of convergence for the Taylor series for f about x equals 2. Well, okay, we've done this before, right? So let's look at our Taylor series is this, right? So what are we going to use? Well, our first go-to, folks, is just this ratio test, right? I mean, that's my always first go-to when I'm finding integrals or radii convergence. So I get this n plus 2 over 3 to the n plus 1 times x minus 2 to the n plus 1 all over n plus 1 over 3 to the n times x minus 2 to the n. And we've done this rodeo before, right? This is nothing new. I'm going to, again, separate out so the n's go on top of each other, and the x minus 2's go on top of each other. And then the 3's go on top of each other. Because that's how they reduce, right? They reduce to a nice symbol. And then that goes to 1, right? This goes to x minus 2. This goes to 3. So we're left with this. And we've been told that rho has to be less than 1. So therefore we know that x minus 2 is going to be less than 3. And that's going to be our radii convergence. I mean, 3 is going to be our radius. Right, so we can write that down. Our radius is 3. And if you don't believe me, you're like, well, I don't see how you saw that. You could just write it out like this, right? Add 2 to both sides. That would be our interval. The center of this is 2, which makes sense, right? The center of this is 2. So therefore, if 2 is the center, 3 is the distance from the center to either end. So the radius is 3. Good. That ties out with the right answer. We're moving on to C. Let G be a function that satisfies. So G prime is f of x. Okay, G prime is f. So G is the antiderivative. So we're just going to take the antiderivative, right? We're just taking the antiderivative of the previous one. Okay, so that's what we need to do. G of x. G prime of x is f of x. So therefore, we're just taking the antiderivative of f. Do I have that right? Yeah, we had to find G, right? Yeah, we find G. So let's take the antiderivative. I guess I'm going to need a C at the end too. I'll put that C in at the end. So the 1, I'm look at this 1. I should kind of tie out this 1 here as an antiderivative of x. This 2/3 x minus 2 is going to have x minus 2 squared. And the 2/3 needs to be divided by 2, right? So that becomes 1/3, right? 2/3 divided by 2 is 1/3. Now I'm going to come up here. This x minus 2 squared becomes x minus 2 cubed. And then 1/3 becomes 1/9. Then we have plus. Okay, wow. This is starting to look like a pattern, isn't it? X minus 2 to the 4th. Then we take 4 over 27 divided by 4. We just get 1 over 27. I'm definitely seeing the pattern. I hope you folks are too. Because it looks like what's happening here is that every one of these terms is just going to be 1 over, well, if this is 0, this is, see how that's a 2? So that means this must be the when n equals 2 term. So that's going to have to be something like 3 to the n minus 1 times x minus 2 to the n. Whenever you x minus 2 squared, that's kind of like the degree of that term. So n is kind of 2 for this. So I think that's 3 to the n minus 1. I might be making a mistake, but we'll check the answer in a second. Now, the problem is here, folks, yeah, I mean, this is technically correct, but look at our formats. For Taylor series, we really want to see x minus 2 here. So the fact that you have x and then x minus 2 and x plus 2, it's not a great way to write it. So a better way to write it, I didn't check our C out yet either, folks. I'll have to check the constant. So the better way to write it would be to have like x minus 2 and then 2, right? That would be a better way to write it. That's probably a better way to write it. Now, I didn't check that initial condition, didn't I? Because when I took the antiderivative, there should have been C here. I didn't check that C. So did they tell us something? They said when g of 2 equals 3. Well, if I plug in 2 here, folks, what do I get? If I plug in 2 here, what do I get? I get 2. So that's a mistake, right? Something's wrong. We have to go in here and change this number from 2 to 3. Because when we plug in 2, we need that to equal 3. Now what if this works? Well, if this is the 0th term, this is the first term. Does this work? I think it actually works for all of them, including the first term. If you plug in 0, what do you get? Yeah, you get 3. Oh, that's kind of cool. I think this works for all of them. Okay. So that looks like the right answer to me. Why do they have a different number? Why do they have... Folks, it looks like the answer key for C is different because they started counting at 1. And frankly, I don't think that's right. Yeah, I like my answer more. I would change that to n in the numerator and 3 to the n minus 1 in the denominator. I don't think that answer is right. I don't know why they counted. Why? Hold on. Was my f of x wrong? Yeah, that's inconsistent, folks. It's inconsistent because the n that they're using for g of x, they're relating it to the n back in f of x. So the reason why that was done is because they're kind of using the n that was done back in f of x. They're trying to see this. The reason their answer key was like that is because they're saying, hey, remember the n you had here? Well, that same n turns into now this n down here. That's why their answer key is different. But you shouldn't do that. There's no need to do that. So, I mean, if it was on a test, I'd take both answers, but this is the better answer, folks, for g of x. D. Does the Taylor series for g converge at x equals -2? Support your answer. Well, no, right? Did we come up with the interval here? Oh, no, that was for f. So to be completely correct, what we really should do is just to make sure this was the radius, folks, for g, for f, sorry, and that was what created g. So frankly, this radius should still be relevant for this. So therefore, I'm of the opinion that no, that the radius is outside the radius of convergence. The interval convergence is from -1 to 5. You know, if we really wanted to do it again, we could. I mean, I got time, right? So we can just say this series here, you know, where does it converge? And we do a ratio test. And I'm not going to bore you with the details of going through that whole thing again. Suffice to say that you're going to get here. Oh, actually, it's going to be like -2, isn't it? No, it's just n. Oops. Yeah, this is going to be -1 this end. So, but lo and behold, it gets you the same place. It gets you here, which you say is here, which again is the same radius. So I just want to make sure I show you that it's the same radius. So therefore, that's our interval. Therefore, oh, that's a +5. Does not converge at x equals -2. That's a cool problem. All right, folks. Hope you enjoyed that walk down assignment 5, and I will talk with you all soon.